Okay, we're talking about the remainder theorem and factor theorem, which you've already done in core 1. Okay, but the difference now is we're going to be dividing things by things like ax plus b. So in core 1, if you imagined your polynomial, which you usually call p of x or f of x, and you were dividing by the bracket x plus a, okay, then in core 1, all right, you had the what I call the magic value of x that you substituted in. There was the remainder, okay, you can find just by substituting the correct value into your polynomial. Okay, what value do I need to substitute into my polynomial? Well, I look at my factor, in this case it's x plus a, so what I call the magic x is the value of x that makes the thing I'm dividing by, x plus a, equal to 0. The reason for this was explained in core 1. So what value of x makes the bracket 0? The answer is x plus a equals 0 when x equals minus a. So you get the remainder by doing p of minus a, and if the remainder is 0, then that shows you that it's a factor. So the factor and remainder theorem are basically the same thing. The factor theorem is the comment you make when you get a remainder of 0. Okay, so if I'm now dividing by the bracket ax plus b, which I am, okay, then how do we find the magic x? Well, the magic x is going to be, when the thing I'm dividing by, ax plus b, is 0. So for the magic x, I need ax plus b to equal 0. So therefore, that's true when ax equals minus b, so x equals minus b over a. So this is just an extension of the same method. If you now look at what it says in order to find the remainder, I need to put that minus b over a, this magic x that we've just found, into the f of x. So this is exactly the same method as we had in core 1. It's just there may be a number in front of the a, okay, and you have to take that into account when you work out what I call the magic x, okay? And then the case where the remainder is 0, so if when you put the magic x in it you get 0, that means the remainder is 0, which means that the bracket is a factor. That's just an extension, just another way of a bit of language we use when the remainder happens to be 0. Okay, so let's have a look at this example now. We've got a polynomial and it's telling us to work out p of minus a third. So p of minus a third, all I have to do is lob minus a third into the polynomial. So it's 6 times minus a third cubed plus 23 times minus a third squared minus 38 times minus a third minus 15. Okay, now I'm far too lazy to do that by hand. On core 1 you'd have had to do it by hand, but on core 3 and 4, I'm allowed to use a calculator. So if I do minus 1 divided by 3, and if I now press store and press the A button, okay, then I've now got my minus a third stored, and all I have to do is enter in terms of A, 6a cubed plus 23a squared minus 38a minus 15. Okay, so I need to do 6 alpha a cubed, not plus 63. Okay, and the next one was plus 23a squared plus, no, not a little big plus 23 alpha a squared minus 38a minus 38 alpha a minus 15 equals, oh, and it's 0. Okay, find p of minus a third, so equals 0. Now if it's a show that question, equaling 0, then you might need to show a little bit more detail. But you are expected to be allowed to use the calculator on this module, so I think this is fine what I've got here. So 0, I could have seen that coming, because look at part 2. It doesn't say hence, but this is how these questions work. The parts lead into each other. So it was not a surprise I got 0, because my comment from that is therefore, okay, an answer of 0 means that something is a factor. Okay, you should be familiar with that from core 1. Now, what is it that's a factor? Well, in core 1, okay, you'd have been using this version of the factor and remainder theorem. So if I've got a value that when I put it into p of x gives me 0, okay, then the factor is x, and there's a sign swap going on. So your first reaction here might be, I put minus a third in, okay, so therefore and I got 0, so therefore my factor is x take away minus a third, which is x plus a third. Now that's true, it's not wrong to say that x plus a third is a factor. But it's a really ugly factor because it's got a fraction in it. Okay, all right. What we've seen from this version of the factor and remainder theorem is that I can have numbers in front of the x, and the magic x is still the value that makes the bracket equal 0. So if this is a factor, a better way of writing the factor is as 3x plus 1, because you can see that if x is this minus a third, the magic x is the same for this one, because 3x plus 1 equals 0 when x is minus a third. And in fact, this factor is just this factor multiplied up by 3. Because we're dealing algebraically, constants, we don't really mind about constant multiples, we mind about the algebraic multiple. So these are just different by a factor of 3. And it's going to be a whole lot neater to use the whole number version than this. Okay, this kind of should remind you of when you're cheating on your calculator, when you're factorizing something like 4x squared plus let's have 3x squared plus 8x minus 3, and you think, I'm too lazy to factorize this, I'm going to use my calculator in equation mode and it's going to tell me what the factors are. So you go into your equation mode and you solve a polynomial equation of degree 2, and you say it's going to be 3x squared and it's going to be plus 8x and it's going to be minus 3, and you solve it and it tells you the first answer it gives you is a third. Okay, now what factor does that mean? If we're pretending to factorize this, okay, well, we are factorizing it, we're just using a cheating method. What am I going to put for my first bracket? Am I going to put x minus a third? No, I'm not. Actually, let's look at the second solution. The second bracket is going to be x, this is a minus 3 as the answer, so x plus 3 would be a bracket. I can now work out what the first bracket has got to be. In order to make 3x squared, I need to have 3x, and in order to make the minus 3 at the end, I need a minus 1, and we can check minus x here plus 9x does give 8x. I mean, the calculator, it won't get it wrong, will it, if you've typed it incorrectly? Okay, so what was that first root again? The first root was, okay, the first value of x was 1/3, and that leads to the bracket 3x minus 1. Not x minus a third, but 3x minus 1 is still 0 when x is a third, but it doesn't have horrible fractions in it. So that's the same reason why we prefer, instead of saying a factor of x plus a third, we like to say the factor is 3x plus 1. Okay, all right, now I've got a factor. I now got to write this is a product of 3 linear factors. We've just revised algebraic division. I know that when I do this division of that by that, it's going to come out without a remainder. So I set up my grid, okay, 3x plus 1 down the side. I need to create, okay, so I'll write it here, 6x cubed plus 23x squared minus 38x minus 15 is going to equal a bracket of 3x plus 1 times another bracket, and then there's going to be a remainder of it. Okay, but because I know this is a factor, I'm expecting the remainder to be 0. Let's see if that works. Let's make the 6x cubed work. So there must be a 6x cubed in my grid. In order to get 6x cubed, I must have 2x squared to multiply by the 3x. But then down here, whether I want it or not, I'm going to get 2x squared. But then these two terms are going to have to combine to give, what do I want? 23x squared. So I've got 2 of the x squared, so I need another 21x squared here. How am I going to make it give me 21x squared? Well, I've got 3x, it must be times 7x. That does give 21x squared, but it also gives me 1 times 7x is 7x, whether I want it or not. Now, how many x's do I want? I want minus 38x. So these two things have to combine to give me minus 38x. So I've got plus 7x, so I need to actually take away 45x from that to get my minus 38x's, and in order to make my minus 45x's, it needs to be 3x times 3 times 15 is 45, so it must be minus 15 here. And if I've got a minus 15 here, then I must have 1 times minus 15 here. And I want minus 15, so it's come out without a remainder. Hooray! That's what I expected to happen. So my factorized version is this factor 3x plus 1 times this factor 2x squared plus 7x minus 15. And now I've got an ordinary quadratic to factorize. So, okay, let's use that cheating method on the calculator, okay? For those of you that are too bothered to set up a little grid to factorize that, you now do have, what are we doing? Okay, I want to factorize 2x squared, so I want a 2 here, I want a 7 here, and I want minus 15 here, and the answers it gives me, okay, first x is, oh, I've gone past it. First x, it says it's 3 over 2, and the second x it tells me is minus 5. So the minus 5 brackets, I've got 3x plus 1. One of those solutions was minus 5. That gives me the easy factor, x plus 5, okay? The other one, if you remember, was minus 3 over 2, but I'm not going to be having x plus 3 over 2 here. In fact, I can see that to make the 2x squared, I need a 2x. To make the minus 15, I need a minus 3. And you can see that that factor there corresponds to that solution of plus 3 over 2. Okay? All right, good. And then finally, so that was part 2. I've just done. And now part 3, I've got to simplify, okay, 6x squared plus 2x over the thing I've just factorised. So the bottom, this 6x cubed plus blah-de-blah-de-blah, is just 3x plus 1 times x plus 5 plus 2x minus 3. And I'm promised that this should simplify. So if this simplifies with this on the top, this must factorise in some useful way. In fact, I can see it's very easy to factorise because there's a common factor there of 2x. Okay, but if it wasn't so kind, I know that one of these factors is guaranteed to appear as a factor on the top. Okay, so if I've got a 2x outside my bracket as the common factor, to make this term I need a 3x inside the bracket, and 2x times plus 1 is here, and lo and behold, this factor cancels with this one, so the answer is 2x over these two. Now, we could go further. We've done partial fractions. We could split this into partial fractions, but the word simplify does not imply do partial fractions. So sometimes you would have to, and it would say what format? It would say write this in the form a over first bracket plus b over second bracket. It may or may not tell you what those brackets were, in which case you would have to carry on and do the partial fractions, but it doesn't, so we won't, and we'll just give our answer as 2x over brackets x plus 5 2x minus 3, and we're done. Okay, all right, that was part A. Part B, we've now got to find the remainder when I divide this by this. I think this is totally unrelated to part A. I don't think we need, I think we can forget everything we've done so far. So find the remainder. Okay, so I've got a bracket I'm dividing by, so I need to work out what my magic x is. Well, my magic x is going to be when the 3x minus 1 equals 0, which is when 3x is 1, so x equals 1/3. So therefore, my remainder is p of 1/3 or f of 1/3. I mean, if this is called f of x, then this is f of 1/3, which is 3 times 1/3 cubed minus 1/3 squared plus 3 times 1/3 minus 2. I don't feel like cheating on this one because it's so easy. This is 3/27 minus a 9th plus 3 times 1/3 is 1 minus 2. And 3/27 is a 9th, so these two cancel out, and 1 take away 2 is minus 1. So my remainder is minus 1. Hooray, that was easy. And then this last part, b dotted 2, given that that is the same as that, find the values of a and b. Okay, well, they've done this term for me, okay? When I divide this by this, I don't know how many x squareds I'm going to get, but this is one of those ones where you can spot how many x's you're going to get, x squareds you're going to get, because 3x cubed divided by 3x is going to be x squared, okay? And in fact, I kind of know what the b is going to be, because this is the division I've just done. So this is the remainder term, and in particular, the remainder b is going to be minus 1. So there are a couple of different ways of doing this, okay? We can do it a little bit partial fractionsy, okay? All right, or we can do it by algebraic division. I'm going to do the algebraic division first because that's probably quite straightforward. It follows on from what we're doing, and you're likely to be thinking, yeah, that pans out the normal way of doing things. So I'm going to do the 3x cubed minus x squared plus 3x minus 2. I'm going to do algebraic division. So I'm going to say the thing I'm dividing by, 3x minus 1 times some bracket plus some remainder, is going to equal this. Set up the grid. So in my grid I need 3x minus 1. I need to create a 3x cubed. So I'm going to need to just 3x cubed to appear here. So I'm going to need to multiply that by x squared, which gives me a minus x squared whether I want it or not. So overall I want to have minus x squared. So I need no x squareds here. So if I need 0x squared here, I must be having a 0x times the 3x to make 0x at the top, and that's going to give me 0 at the bottom. And these two terms are going to have to combine to give me the correct number of x's, which is 3x. So I've got 0x here, so I must have 3x here. And 3x times 1 is going to give me that 3x. So I'm going to have x squared, and I'm going to have minus 1 times 1 is minus 1 here. And then these two terms are going to have to combine to give me, this is where the grid ends, so this one here is a remainder. Okay, minus 1 times 1 is minus 1, so I've got minus 1 already, I need minus 2, I must have another minus 2, so there's my remainder of minus 1. So I've got a remainder of minus 1 here, and inside the bracket I've got x squared plus 0x plus 1. Of course I can miss out the 0x from now on. And in fact, actually, the question was giving me even more help, because you'd normally expect to have x squareds, x's and a constant. They're telling me the number of x's is 0 for free. Okay, I didn't use any of those hints. I've done this using the algebraic division method from scratch. I've got the reward of having a couple of things checked for me. So I got 1x squared, I didn't get any x's. Okay, and I did get the remainder of minus 1 that I was expecting. So there's all kind of double checking built into this. Okay, so my answer, if I do the algebraic division, is going to be 3x squared minus x squared, 3x cubed minus x squared, plus 3x minus 2 over the bracket of 3x minus 1 equals, okay, the quotient part is just my x squared plus 1, and my remainder is minus b over minus 1 over 3x minus 1. So a equals 1 and b equals minus 1. Okay, so that's the algebraic division way of doing this. Okay, all right. Now the smart aleck way of doing this, okay, which is a wise for you to see, okay, when they've given you so much help, which we saw they gave to you, we're saying, or they're telling us, that 3x cubed plus x squared plus 3x minus 2 all over 3x minus 1 equals x squared plus a plus b over 3x minus 1. And we can have this like we do with partial fractions. We can multiply both sides by the 3x plus 1, and then we can substitute in any smart values of x we feel like. So if I do that, I'm going to get 3x cubed plus x squared plus 3x minus 2, okay, equals x squared times the 3x minus 1 plus a times the 3x minus 1 plus the b over 3x minus 1 times b times 3x plus 1 is just b. Okay. Oh, and I can use a little bit of intelligence here. This is the remainder term, and I knew from a previous part of the question the remainder is going to be equal to minus 1. So actually I can just say this bit here is minus 1 over 3x minus 1 times 3x minus 1, which is minus 1. So in fact the only thing I've got to find is a. Okay, I could substitute in values of x. Now you might think that x equals a third is a smart value of x, but actually that's going to make the a that I'm trying to find vanish. Okay, that would be a good way of finding the minus 1 if I didn't already know it. But I'm not going to put in a smart value of x, I'm just going to put in an easy value of x. And the easiest value of x here is definitely x equals 0. Because when x equals 0, okay, all of this is 0. I'm just going to get minus 2 equals, x is 0, so this bit is going to equal 0. Minus 2 is going to equal a times 3 times 0 minus 1, which is a times minus 1. And I mustn't forget this minus 1 at the end from there, so I need a minus 1. So this is telling me that minus 2, so minus 2 equals minus a minus 1, okay, which solves to give me a equals 1, okay? And I already knew that b equaled minus 1, so I've got the same values for a and b, 1 and minus 1, that I did before, but this time I've used the information they gave me, and I've used a slightly partial fractions-y kind of multiply up and then substitute in x values method, so you can see that there's sometimes more than one approach for this kind of problem. I hope that helps.